Okay, let's start. Hello, everyone. Thank you for joining us today. My name is Ebru Taylak, and I work on marketing at UberCloud. My background includes nearly a decade in the CAE field with a main focus on automotive projects, and I have also lots of hands-on experience running HPC simulations. And today, as a part of our webinar series covering different industries, we are going to talk about CAE simulations for automotive in the cloud. So automotive industry has changed so much over the past decade. Most of us attending this webinar probably remember the times that electric vehicles were still struggling with adoption and autonomous vehicles were considered pretty much science fiction not long ago. Today, auto companies have become tech companies. While old problems still exist, there are so many new ones. There's an ongoing race for developing electric vehicles, advanced driver assistance systems, and autonomous vehicles. And with these, there's a new focus on development areas such as deep learning, antennas, batteries, electronics, sensor design, including radar, LiDAR, cameras, and many more things. So one thing that hasn't changed is that engineers are still using simulations to answer their questions. On top of the old questions, such as how do I ensure structural feasibility? How do I keep occupants safe during a crash? How do I reduce weight for fuel efficiency? How do I cut emissions? There are additional questions now, such as how do I increase my battery range, which brings a focus on battery technology, but also aerodynamics of the vehicle. So how do I compensate for the added weight introduced by the batteries, which relates back to this? And where do I place my sensors to get accurate readings on all weather conditions? How do we get to zero fatalities? So these are some of the new questions engineers have been asking and using simulations to answer these. And there are companies with ambitious goals out there. For example, Volvo publicly announced that they target to achieve zero fatalities by 2020, which is 1 year from now. And Volkswagen announced that they will stop making gas and diesel cars by 2026 by good. So in fact, with these new focus areas in automotive development and the ambitious goals, simulation workloads are increasing fast. And what we often hear from the industry is that in-house clusters and workstations are starting to fall short to keep up with the increasing number of the simulations. So while electric vehicles have progressed and continue progressing, it is expected that 30% of all vehicle sales will be electric vehicles and hybrid electric vehicles by 2025. And vehicle production will increase to over 130 million in 2026 from less than 100 million today. And right now, there are more than 1,700 startups working on technologies to disrupt the automotive industry. So all these point out that companies will be running more and more simulations to stay competitive. And with all the competition, it will really become critical for them to cut development and production costs and speed up their time to market. And so how do you achieve this? To answer this question, let's take a glimpse into cloud computing. So we all know that automotive simulations are complex, compute intensive, and highly depend on parallel computing. And cloud, on the other hand, provides engineers with endless, scalable, on-demand compute resources. So combining these two, engineers can benefit from simulation in the cloud, boosting their product development performance and stay competitive. There are many benefits of cloud computing for engineers, and I would like to highlight some of these. First of all, there's no longer any need for modeling trade-offs. Now engineers can run detailed complex models and get the most accurate results from their analysis by getting access to all the compute power they need. And having these accurate simulation results leads to reducing the number of physical prototypes. And we all know this can be very costly for the automotive industry. Second, being able to run multiple analyses in parallel without having to wait in queues, scaling up compute resources on demand speeds up the whole development cycle, and which helps bring products faster to market. And third, resources being accessible from anywhere on any device will help better collaborate within a team. So most automotive development teams today are spread out around the world. For example, if you have an office in the USA and one in Germany, you can easily access each other's models in the cloud, review simulation results, and reiterate on the design, submit new simulations. And finally, cloud gives you a lot of flexibility to try out new things and innovate. An example could be running multidisciplinary design optimization, which becomes more and more crucial with all the different engineering disciplines involved in automotive development today. So all that being said, let's get to the interesting part. So how do you get started with running your simulations in the cloud? So you may be experienced in engineering, running simulations, CAE, but here there is a lot of dependence on IT. Setting up simulations in the cloud environment require a lot of know-how, HPC expertise, and also cloud expertise. There's the initial setup, which is very complex, consisting of configurations of parallel processing and software deployment in the cloud. And then there are activities around selecting the right hardware and tools for the job, as well as setting up the necessary tools to support your engineering workflows and providing easy means of access to the compute environment. But it doesn't end there. Then there's maintenance for different software versions. There's also ongoing operations, such as adding, removing nodes from the cluster on an ongoing basis. And this can be a big cost saver for your team because at the end, your cluster won't be utilized 24 hours a day, and you probably don't want to spend money on something you are not using. And then there is also support needed for things like break fix services. And believe me, so your compute nodes can fail, and you will be needing this. So when picking up a cloud simulation partner, it is important to make sure they cover all these steps. Some providers will provide you with cloud access, but will leave the rest at your hands. So at UberCloud, we provide engineers with a full solution for simulation in the cloud, including hardware, software, and support. We have partnerships with all leading CAE software companies, as well as cloud providers such as Microsoft Azure. And you can see here some of the applications we are currently supporting, like ANSYS, CSV, HEATS, ls-dyna, Star CCM+, MATLAB, COMSOL, Abacus. There's also a lot more that's not shown in this picture. So our Cloud CAE platform gives engineers seamless access to the cloud with their desired CAE software pre-installed, configured, and tested through UberCloud CAE container technology, and also configured with the hardware that best fits with the type of analysis they are running. And once the engineers get access to the system, they can start running their simulations immediately. And then through Microsoft Azure, they can get the latest best-in-class hardware, such as the latest Intel CPUs, NVIDIA GPUs on demand. And we can set up the clusters with as many CPUs or GPUs that are needed. so that all simulation jobs can run in parallel without having to wait in queues. And best of all, you can continue using your existing workflows like you're used to in the cloud on a desktop-like environment. So there's no new tool in the middle. All you need to get started is to go online and open up a web browser. And this is how it really looks like. So once you sign up, you receive a welcome email, and you click on the login button, type your password here, and you're in your cloud compute environment. So it just looks like any other desktop. There's really nothing new to learn. You can continue using your existing workflows. And our GPU-enabled visualization technology provides high-quality 3D rendering and model manipulation in the cloud so that you can work seamlessly. And here in this example, I have my ANSYS graphical user interface window, and I can run simulations interactively through the user interface, or I can use a command line window to submit jobs. Like I mentioned, there's nothing new to learn, and you can use your existing workflows. Now let's take a look at some UberCloud case studies. To begin with, let me mention that these studies were performed as a part of UberCloud Experiments. We partnered with different engineers, scientists around the world, as well as software vendors and cloud providers, and took their simulations to different cloud environments. And all these experiments were sponsored by HPE and Intel. So for the first use case study, we'll look at a vehicle crash with ANSYS ls-dyna in the cloud. This is for the simulation of a frontal impact. The vehicle is hitting a rigid wall, and we are looking at the resulting deformations in the car body. And this simulation uses the ANSYS ls-dyna solver on the UberCloud CAE platform. The team here, they started the simulations with a coarse mesh, and then refined the mesh size to more accurately capture the crash behavior. And refining the mesh size resulted in an 11 times larger model. And they were able to complete the simulation for the refined model on 128 CPU cores in the cloud in less than half an hour. Just to give you an idea, the very fine mesh model slows down the simulation from less than 2 hours to 19 hours on one CPU core. So this brings us back to the point that with cloud computing, it is no longer necessary for engineers to do any modeling trade-offs. They can do as detailed analysis as they want. And considering during the development cycle that these models need to be rerun at least tens of times, if not hundreds of times, to evaluate different design parameters. Another benefit is brought by the fact that with unlimited compute resources in the cloud, engineers can submit all jobs simultaneously without having to wait in queues, and resulting in a significant speed up of their development cycle. Here is another case study for racing car airflow simulation with ANSYS Fluent in the cloud. And for the aerodynamic study of a race car with ANSYS Fluent study, the engineers wanted to understand the air velocity and its impact on the car's stability during racing at different speeds. Here, besides the simulations being run in the cloud, also the pre and post-processing were performed in the cloud through the GPU-enabled visualization technology provided by UberCloud. And here we are looking at simulation runtime results for 14 million mesh size model compared to a 10 times larger 140 million mesh size model. And comparing the results, so increasing from 32 CPU cores to 128 CPU cores, we see that with large size models running on 128 CPU cores in the cloud, we get a speed up of 4. And the whole simulation takes slightly about 1 hour to complete. So our last example is for an airbag simulation with ANSYS ls-dyna in the cloud. And the main objective of this project was to analyze the airbag inflation behavior under dynamic conditions. And simulations were run on the UberCloud CAE platform with ls-dyna as a solver and Microsoft Azure as the cloud. For this simulation, the steering wheel is fixed and the load curve provides the airbag opening forces, which are defined on the airbag component. And in the picture, you can see the opening sequence of the airbag as well as resulting stresses on the airbag material. And so the team again you can see on the charts here that the team did studies on different mesh densities, and they were able to complete the simulation, which accurately predicts the results for 132,000 elements in less than an hour. So this brings us to the end of this webinar. So we talked about the changing automotive landscape, the increasing demand for simulation, how engineers can benefit from the cloud. And we also talked about the challenges of the cloud and how UberCloud can help overcome these. And also looked at some example case studies from the industry. And we are interested to hear about your challenges. So email us if you would like to learn about how we can help you run your simulations in the cloud. And visit our website to take a look at the collection of case studies, compendiums, white papers, and guides we have available. And now we have some time left and we'll be taking some questions. So please type your questions into the Q&A window. Okay, so one question I received here is how does licensing work? So that's a good question. Based on the licensing model offered by your software vendor, you can use pay-as-you-go or annual licenses. And then you need to bring your own licensing, meaning if you have an existing license, you'll be using that to run your simulations in the cloud. Let's see if we have any other questions. Okay, I see another question we have is, are different versions of the software available in the cloud? Just to answer, yes. Cloud gives us a lot of flexibility, and then using the UberCloud technology, we can easily make different versions of the software available for you to run in the cloud. And then all you would need on your end would be to have the required licenses to run the software. So one other question I have is, can I use job scheduling and automation for my simulation jobs on UberCloud? And again, yes, you can continue using your existing workflows in the cloud, and we integrate with many of the commercial and open source job schedulers. Okay, so this brings us to the end of our presentation. So thank you very much, everyone, for attending, and bye.